First of all, thanks for the NSLondon organizer for having me here, and also New Day for hosting the event. I'm going to talk to you about how we evolved the search functionality of the iOS app of Yelp. Before doing that, if you don't know me, I'm Andrea. I'm Italian. I'm born in Brescia, which is a city in the North Italy, which I usually explain that as not far from Milan, which is roughly a good approximation. I'm based in Bristol. I don't live in London. I moved there 5 years ago. And I love pizza without pineapple. Of course, sorry guys. And I joined Yelp 3 years ago. I work in the Search UX mobile team, which is a long name to say I just look after the search experience. So every time I look for a business on Yelp, on the iOS app, that's basically my team. I also look after the app clip. So if anyone's interested in app clip and want to chat about app clip, feel free to reach out. So if you don't know Yelp, Yelp is pretty famous in the US, way less in Europe. So Yelp mission is basically about connecting people with great local businesses. It's basically the place where users go to leave reviews about restaurants, services, retail shops, and the place where they go for searching for them. So as you can imagine, search is pretty important. It's one of the core functionality of the apps. It's basically where users go to search for different businesses. It's where we show the results on both the search list and the search map. And we also offer a bunch of other features like filters, refinement options, way to connect directly with a business directly from search. So it's very complicated and very rich in terms of features. This year marks the 20 years of Yelp. It basically launched in 2004, the website, yelp.com, in San Francisco from our co-founder and CEO, Jeremy. And this is one of the oldest screenshots I managed to find. And probably you might know that. The iPhone App Store launched in July, I think, 2008. It's when Apple finally opened the doors for third-party developers to develop apps for the iPhone. And on the day of the launch, there were like roughly 500 apps, and Yelp was one of them. That's, I think, a frame from an old commercial I managed to find. This is how search looked back in the days. So remember, this is 2008. So there is no Swift. There is no automatic reference counting. There is no Swift UI. There is no auto layout. There is no Alamo Fire or any open source framework. That's like the old school of holding apps, of creating apps. Pretty incredibly, this is like a UI table view. And UI table view had a very good API design since the day one with the idea of reusing cells. And also, one of the things that actually Yelp managed to do very good is preserving the Git history of the iOS repo. So I actually managed to check out and read myself the code from 2008, and it's pretty crazy. I even tried to compile it and run. Obviously, it doesn't find iPhone OS 2.0. So if anyone knows how to make it run, please reach out, because that would be very cool. So in 16 years, definitely a lot of things have changed, both in how we develop iOS apps in the industry, but also how Yelp works. So in 2008, we had a couple of engineers working on the app, so pretty simple. Definitely modularization wasn't a thing. Like, there was just the main app. There wasn't even like the need of modularizing the app. Everything was Objective-C. The UI was built in just one way, programmatically, and a bit of zip files I found here and there. And search was simple, just a plain table view of restaurants. As you can see, like, the layout is pretty easy and simple. Bit more complicated today. 16 years later, so we definitely have way more engineers working on the app. Modularization is definitely a thing. We definitely need it. We have over 50 modules at the moment. we have a mix of Swift UI and Objective-C. So Swift and Objective-C. So Swift definitely the way to go for new features. But we still have some very old core components that power the app in Objective-C. And I'm going to show you one. The way in which we build UI changed. So we built internal frameworks that help our developers in building UI faster. We still have programmatic UI. We have like a lot of ways to build UI in Yelp. Search is a bit more complicated, and we're going to see why. We consider search now as a list of components. And we also have a bunch of other things from industry. So A/B tests, experiments, feature flags, analytics events, anything that you can imagine. So complexity definitely increases. So I'll show you quickly a couple of things. So a bit of the network layer and a bit of the UI layer. I cut a couple of slides. And I'm going to show you some high-level things and solutions that we have. So I promise there won't be much code to read, because I know it's late. So let's start from the network layer. So fun enough, the API was actually iPhone_search, because obviously in 2008, there was only the iPhone, apart from the website. So they actually built an entire new API just to serve the iPhone app. It was pretty easy. So in the code, you had like an Objective-C object, the search request, that represents the search request that you want to do with all the parameters. And then you get the response from the server, and we parse it into the search response object. And keep in mind, the UI was simple. So the only place to perform a search was the search bar on the UI. That's all. So today, we definitely have a more generalized API, because we have more clients to serve. So we don't have the iPhone search API anymore. We still have the search request and search response. So 16 years later, they are the same classes. I'm pretty scared of touching them and converting them in Swift, as you can imagine. We definitely have way more parameters on search and way more things to parse in the search response, but the files are actually still the same. So as I said, search increased in complexity. And one of the things that's more complex now is that we have more places in the app that can actually trigger search. So we have push notification, deep links. We have a lot of flow and features that across the app want to launch a search and trigger a search. So to abstract feature developers from the complexity of search, especially because it's also Objective-C, we created the search intent object. That's the public object that everybody in the app is using if they want to perform a search. That's like their public interfaces. They basically express, in this case, a very simple search. It's like the term and the location of the search. We take the search intent internally in our search module, we convert it into search request, and then we parse it in a search response. It's a unidirectional flow. That means that if the user perform another request or they try to refine their search, for example, applying a new filter, we take the previous response, we convert it a new search intent object. From there, we get a new request and a new response. I cut a couple of slides here, so there was another thing I wanted to tell you about the network. But we're going to move on to the UI layer, which is a bit, there's a bit of meat there. So this is how the UI looked in 2008. So we have a search view controller with a child view controller, the search results view controller. So if you think about that, they were using already child view controllers in 2008. I found it pretty interesting. We had like the search bar, and then inside the search bar there was a button, the map on the right, to access the map view controller. The results view controller, it's just a simple table view, classic, with the data source and the delegate, super simple, with one type of cell, the results cell, and the UI is pretty classic, I would say. A couple of labels, some things here and there, everything put together without auto layout, which is pretty interesting. Today, the UI is more complex. So we moved from a list of restaurants into a list of components. So we don't show one type of cell. We show a lot of them. We don't show only restaurants or businesses. We show a lot of type of components. We can show results, we can show a carousel, we can show a grid, we can show a survey, all in the same table view. So to manage this type of complexity, and then as you can imagine, I have like a lot of teams across the org reaching out. I want to add my component on search if they perform a particular search. So to manage all of that, the architecture of the app came in helping us. So we have a component-based architecture. So we basically have a hierarchy of components. Each component can have subcomponents, child components, and components communicate each other raising events. Events can go up and down the chain. And that basically helps in decoupling and isolating complexity. We're just taking, imagine like a big fat code base and just dividing into little components that can be reused across the app. And in this way, we can also assign ownership very clearly. In the case of a table view, that's how it works in our app. So the table view is actually a big component. Table view directly manages section component, and section components then are entitled to manage directly cell components. In this way, we don't have a very fat table view data source or a very fat table view delegate. So this is how it used to be, the code to understand which cell was clicked. This is how it works today. So today we just understand the component and forward the action to the component, and then the component knows what to do. Another thing that evolved over the years is that the layout of the SERP card changed. So instead of having one single UI for any type of business, we offer a different UI based on what you're looking for. So if you're looking for restaurants, probably you value photos. If you're looking for a plumber, probably you want to have more information about the plumber. If you're looking for a hairstyle or gym, a retail shop, any type of business, you probably value some different things. So based on what you search, we offer a different UI. How we manage that? So we have this solution. It's called backend-driven SERP card layout. I should have come with a better naming, a more fancy one. It's basically a puzzle-based solution. It allows us to create a layout configuration based on the type of search, the type of business, any location that you're using, any type of filter, and having directly this layout configuration coming from the server. This enables product to have experiments and to run an experiment with different type of layouts, and it also solves our problem of having a very complex code base. How does that work? So the results component, the business results component, you can think about that as a composition of different UI views. And each UI view or each view can have different type of layouts. This is how it works. So we have this idea of templates. Each UI element can have different layout, different templates. The template basically takes as parameters the domain model. So in the case of the photo carousel, the array of photos. It takes the layout configuration, which is what the backend is sending, and a bunch of other dependencies like experiments, the analytics manager, anything that you can think about. The goal of the template is to then generate a view model that actually represents how the view is going to look like. Then we take all the view models from each view, we combine them together into the bigger view model that represents the business result, and from the view model, we generate the view. In this way, the view model is basically a snapshot of the view. It's a unique representation of the view. If you want to change the view and how the UI looks like, you need to generate a new view model. And then from the view model, we're going to actually generate a new view. I told you I kept this short. So to recap, a lot of things have changed, like a lot. But we still do the same things. We still show businesses. We try to deliver results to the UI as quickly as possible. We use a composable architecture, and then we try to have a custom UI based on what you're looking for, and that's what basically we work and we experiment on every day and every month. So thank you a lot.